Welcome, my name's Mike, M0MSN, and I have been challenged. By MAV to build an experimental dual band high gain flower pot antenna if the weather's inclement. Well, the weather is inclement, so let's build this this flower pot antenna. And just in case Gollum's watching, antenna, not antennae.
Not listening.
Okay, so the design is documented on the internet. It's by VK, that's Victor Kilo 2 Zulu Oscar India, VK2ZOI, and it's reported to have reasonably high gain on the 2 meter and also on 70 centimeters, a 3 dB gain on 2 and a 6 dB gain on 70. It's a relatively involved antenna, but I'm changing the design slightly in the hope that it will be easier to build. But yeah, okay, well, let's start. So the first thing we need apparently is roughly 2.5 meters minimum of 25mm conduit. Well, I've got a 3 meter length here, so we'll use that, and also a 6.5mm drill bit to drill the hose for the coils. The first hose drilled 930mm or 93 centimeters from the top, and then the next one drilled 3.5 centimeters or 35mm further down. So let's mark the pipe and drill those holes. Okay, so the pole is marked at, better check the measurements, I think it's 93. Here we go. So it's marked at 93, and then 3.5 centimeters lower it's marked again. This is for the drill hose. Okay, then the next one is marked at 95 or 90.5 centimeters, and then the next one's 4.5 centimeters below that. And I've marked an additional one on the side here to let the coax out afterwards, and then the remainder of it you can bury in the ground or in a flower pot, and we'll see. Anyway, time to start drilling the hose. Okay, just to make my life a little bit easier, we'll shorten the length for the pipe a little. Let that pop. Really need to sharpen the blade on that, I think. It's beginning to squidge the pipe rather than cut it. I've got some good quality coax actually. I bought some mil-spec coax for the Gain Master. So I have some left over from that, and I just want to make sure that the drill bit I've got is going to be the right size. Yeah, that's 6mm, so 6.5, which this is probably too big. Yeah, that's it's a 7mm. Let's see if I've got a 6.5. It's a 6mm. It's a 5.5. So that might do the job with a little bit of wiggling. Seven turns to begin with. So let's see if we can work out how much we need of this. There's probably a cutting list on one of these bits of paper. Let's have a look. Ah, there is. Oh dear. Okay. So I'm going to use, instead of using this sheath, I'm actually going to solder on the end piece using 1.5mm, 1.5mm or 0.5. Normally says, doesn't it? Yes, 1.5. So I shall solder 1.5mm to this, and that will be the top piece. Just to save my coax, really. So I need 70 centimeters, yeah. 700 millimeters. Okay, let's measure this. And that'll be the point where I need to then cut the braid away. Goodness. Okay, that's the point there. It's 45.7. My goodness, that is dead accurate, isn't it? Let's mark this. Bingo. 457 millimeters below that point. That's where the sleeving starts again. coax. Let's have you. I'm sure there's easier ways of doing this. Spot on. Okay. 45.7 millimeters. Right, let's put some heat shrink on those. And I think what I might do is put a little bit of glue line so it can't move. That might be just a little bit too big. But we'll accept it. I'll just make the hose bigger. Okay, so what I've done is I've put some glue line heat shrink over the joint where I've cut back the shield. Now, I need to make another mark, which will be 44.7 centimeters down, or 447 millimeters down, and that marks the top of the coil, top of the choke. So I'm going to use another bit of heat shrink at that 44.7 centimeter point. So bear with me while I measure that out, heat shrink that on, and that will be the point which is the lower segment of the diapo. It will all become perfectly transparent later, honestly, he says, hopefully. Right. Magic. And let that glue off. And hopefully the centre of that point is the 44.7. So let's just measure that to make sure. Yes, it is. So here I am cutting the end off the coax to add 93 or 94 centimeters of copper wire. It's just the center core that needs connecting. Okay, we need to solder that together with heat line. You know you hate it when you hit the wrong button, right? Never mind. Okay, so this is the wire that I've soldered onto the end of the coax. Okay, so that's soldered to the center core, and there's the braid folded back, and then I've just covered it with some heat shrink. Now this is supposed to be 97 centimeters, is it? Could be less, bear with me. 92 centimeters long, but I've got about 3 meters there because I'm going to use it as a fish, and I'll show you what I mean now. We're going to use this bit of cable as a fish. What that means is we're going to push it down the rod and then fish it out at the other end. There's my bit of cable. Yay. Okay, so apologies. I basically fished the coax through the top or bottom hole, if you like, and then brought it out of the bottom top hole, and then wrapped it around the pole. There's 7 turns here, not particularly tight. I must say. I must perhaps redo that. I could redo that because it looks a bit loose. And then poked it back through the top hole, and then from that point there all the way to the end, it's just the wire. Okay, so the wire. This is the point where the wire was soldered to the coax, center core of the coax. This is purely the outer braid and the center core. The center core is then, or the outer braid I should say, is then detached here, and it goes down 46 or 45 centimeters to about this point, and then from that point downwards it's the whole coax again, and it's popping out of this hole. And this is where we're going to put our 9 turns as the choke. Then I'll feed it back through here, and this will be the exit point for the coax. So there's the beginning. So 1, 2, 3, 4. Get that nice and tight. Needs to be tighter. Just a second. It needs to be tighter to that one. That's all. Right, let's count that. 1, 2, 3, 4, 5, 6, 7, 8. Need one more. Am I going to get one more? Might do. Yep, I can. Jolly good. So there's the. Now I've got another fish on the end of this. I'm going to see if I can get it to come out of that hole. Should be fun. Should be immense fun. There it is. Oh, I didn't see it. What a shame. Quite proud of that, to be fair. So, just put another bit of heat shrink on that. And that's our base coil done. See how big it is, see if we've got enough heat shrink. Or just. Yeah, it's only just, but it will do. Wonderful. Okay, trying my hardest now to focus. This has actually been a relatively easy, but at the same time challenging build. The top section is as per the instructions. Would it be easier if I do it that way? All right, here we go. So this top section, I've got some yellow and green heat shrink capping the top of the pole, and inside the top section to the coil there is 92 centimeters of bare wire, okay, or I should say PVC insulated wire. It's 1.5 mil, but that's not overly important. Then we have a coil. The coil is 7 turns of RG58, and this is mil spec, this particular RG58, and it is complete. It's both the centre and the external cores just wrapped 7 times around a 25 mil former, and that is 700, that is 670 millimeters or 67 centimeters in length, but as I said, it's 7 turns around this former. Then inside there, so let's go back to the diagram. So this is the coil here, okay, but obviously it's turned into a coil. Then from this point to about halfway down the rod, of this section of the rod between the 2 coils, okay, is 45.7 millimeters, and that was so accurate, it's unbelievable, of just the center core of the coax, and then from about the center point down to the top of the coil, there is 43.6 centimeters of coax with the braid, okay, down to the top of the coil. And then the coil is 9 turns of the RG58 around the 25 mil former, before it then disappears again into the pipe work, and then comes out about I don't know what you call it, 25 centimeters or so below it, and on the end of that I'm going to put a 259. But before I do either of those things, I'm now going to have to put some sticky back silver foil, aluminium foil, in the center of both these segments of the PO. Okay, next thing is the silver foil, the sleeves. Now, the sleeves have to be 23.5, both of them. 23.5. Okay, 23.5 it is. Here's the silver foil. And the stuff I'm using is the conductive version, just to show you that. Yep. It needs to be 23.5. Tape measure up. And 2 at that. Two at 23.5. This, by the way, is class 0 tape for ducting, and works incredibly well. .5, get the centre of that. There. There. Now, the centre point is difficult at 32.4 to the base. 32.4 to the base. Okay. Didn't expect it to take 2 weeks to undo. There you go. the 706 Mark II Golf, 145,400. Okay, 145,400. 145,400. 1.04 and 38 watts. Okay, let's 1.3, 1.4. How many watts was that? 15 watts. This is on 2 meters. Okay. Well, there you go. There you are. It's the finished article. What you have basically at the top is a half wave with a parasitic 70 centimeter section. That's the silver foil there, and then a phasing loop, a phasing coil, which is 7 turns, and then a half wave diapo below that. On the fundamental, again with a parasitic 70 centimeter silver foil addition. Then at the bottom you've got a choke to take the RF out for the return, and that's a 9-turn coil. Finished off with a SO239. Okay, there we are. Thanks very much for watching. If you enjoyed it, give us a thumbs up and please subscribe.